At synthetic division today and how we can use synthetic division to solve polynomials. So it is essentially a method in order for us to find factors of polynomials and or to evaluate polynomials. So the first thing that we want to look at is our remainder theorem. So our remainder theorem says that if you have some polynomial and you divide it by some x minus h, then the remainder of that is the remainder of that is going to be what f of that k value is going to be. So that's essentially saying that if I were to plug in and evaluate, you're going to still get that same thing. So let's take a look at a problem here. Okay, so when we evaluate this, here is our function, and it's saying to find f of 5. So in synthetic division, we're going to put 5 in our box. And synthetic division, if you recall, is when you use the coefficients of your function or your polynomial, and you just have to make sure that you are not missing anything. So you're going to look at the degrees, and that's really a 1. And then technically this is like x to the 0 is right here because that goes away. So 3, 2, 1, 0. I'm not missing anything because my powers don't, they go in descending order. So I just look at my coefficients. I have a 1, I have a -4, I have a 9, and I have a -6. And so we set this up. I'm just going to put a 0 here because remember, nothing can go here. We're just going to drop this 1 down. And then our process of synthetic division, we take our number here times this number, so 5 times 1 gives us 5, and we place it under our next number. And then we add these two together, gives us 1, so 5 times 1 is 5. Add these two together, and I get 14. And then I take 5 times 14, which is 70, and I add these two together, and I get 64. And this last number is our remainder. And what this is saying is that, oops, I forgot my n, is like if I were to plug 5 into that, so like if I were to take 5 to the third power minus 4 times 5 to the second power plus 9 times 5 to the first power minus 6, if you type this in your calculator, it is going to equal 64. So what synthetic division does is you do synthetic division, and whatever that remainder is, that is the value. So that means f of 5 is 64 in this problem. Okay, so just as a reminder, solutions in a polynomial is where they cross the x-axis, which is when y is 0, or f of x, and other names for these are your zeros, your x-intercepts, your roots, your solutions. So synthetic division helps us find these, and they are solutions if the remainder is 0. So whenever you do synthetic division and you get a remainder of 0, then that particular binomial is going to be, or value is going to be, a solution to your problem. Okay, so let's actually do synthetic division. So we're dividing by x plus 1. So synthetic division, remember, says you're going to do the opposite. So that number, if it's x plus 1, if I were to set that equal to 0, then we would get x equal to -1. So -1 is the number I put in my box here. And then I look at my coefficients. I'm not missing anything. So I have 1, 3, 11, and 9. And then I'm going to plug a 0 in because I'm going to bring that down. And then I just multiply. -1 times 1 is -1. I add and I get 2. I multiply and I get -2. I add and I get 9. I multiply and I get -9. I add and I get 0. So because I got 0, that means that x plus 1 is a factor of this particular problem. So I have x plus 1 because that's what this comes from. This is my x plus 1. And then remember, the other part is going to come from here. And this part right here, because we've factored out an x using synthetic division, this power of 3 is now going to go down to a power of 2. So I go x squared, and then I just go down from there. So that's going to be an x, and then I won't have one. So the other part of this is going to be x squared plus 2x plus 9. And that would be my factored version of this particular problem. Let's look at one more. So again, we have x plus 2. So if you think about x plus 2 equal to 0, you're going to have negative 2 as your solution. So negative 2 is what's going to be in my box here. And I'm not missing anything. So I have 1, 7, 13, and 6. Bring down my 1. If I multiply, I get negative 2. If I add, I get 5. Multiply and you get negative 10, and then 3, and then negative 6, and we get a remainder of 0, which means negative 2 is a solution. And so we have x plus 2 as one of our factors, and then remember this part is where our other factor comes from. And because our problem began with a power of 3, my next part is going to be a power of 2. So I have x squared plus 5x plus 3, and there would be my factored form. Okay, so now let's just practice factoring when it might not end up becoming a actual factor of it all the way, and you end up with a remainder. Okay, so just it says factor. So again, this is x plus 2. If I were to set that equal to 0, my factor would be negative 2. I have 5, 4, 3, 2, 1, 0. So I'm not missing anything. So we have 1, 3, 2, 2, 3, 1. So I bring down my 1, I multiply and I get negative 2, I add and I get 1, I multiply and I get negative 2, I add and I get 0, multiply and get 0, add and get 2, multiply and get negative 4, add and get negative 1, multiply and get 2, add and get 3. So that 3 is my remainder. So when we write this in factored form, we're just factoring it because this is a power of 5, this is going to be a power of 4, which means this is going to be a power of 3, this is going to be my power of 2, and this is going to be my power of 1. So I really have x to the 4th plus x to the 3rd. I don't really need to write that because it's 0, so then I just write plus 2x minus 1, and then our remainder, because it's positive, I'm going to say plus 3, but then you'd put it over that x plus 2. So that would be how we would write our factored form.